You are a pilot of next-generation Jaegers. Before assignment, you undergo tests for endurance, reflexes, cognitive stability, and neural compatibility. Drift 2.0 reduces brain load, filters emotional spikes, and corrects motion delays, while the built-in AI stabilizes the Jaeger's gait and keeps control even under heavy impact. But operating a Jaeger is still demanding. Overloads can cause orientation loss and brief motor desync. Your training includes full-motion simulations, stability drills, and synchronization tests. Any mismatch between pilots disqualifies the pair. Even with modern systems, risks remain: drift overload, vestibular fatigue, and cognitive divergence. Neural-compatible pilots are rare, making every trained pair a valuable and difficult-to-replace asset. Gypsy Avenger. Height, 266 feet tall. Weight, 2,004 tons. Two-pilot. Main weapons include the plasma caster, a high-energy range system, and the Chainsword 2.0 for close combat. The Mark VI reactor provides stable power output and supports the gravity sling, a kinetic manipulation system for moving objects at range. Gypsy Avenger maintains high structural stability and is built for extended operations. Gypsy Danger was a Mark III unit built with older steel alloy armor, slower shoulder actuators, and a high-latency neural interface that increased drift load on pilots. Its nuclear reactor delivered uneven power output, forcing the frame into short burst-based combat instead of sustained operations. Mobility was limited. Hip rotation, arm recoil damping, and torso pivot speed were significantly lower than modern standards. Gypsy Avenger replaces these legacy components with updated servo assemblies, composite armor panels, and a stable Mark VI reactor. These upgrades eliminate the motion lag and power fluctuation issues that defined the older Mark III platform. Saber Athena. Height, 249 feet tall. Weight, 1,628 tons. The most agile Jaeger of the new generation. Dual plasma blades allow rapid consecutive strikes without losing balance. Lightweight Mark VII armor reduces mass and boosts torso rotation speed. Maximum safe movement speed reaches 99 miles per hour over short distances. Enhanced servos give it the lowest motion latency of any Jaeger. Bracer Phoenix. Height, 230 feet tall. Weight, 2,128 tons. 3-pilot configuration, 2 control pilots, and 1 dedicated gunner. Armed with the Thundercloud Mace, a high-impact melee weapon, and the Vortex cannon mounted on its artillery module. The frame is built to absorb heavy frontal hits. Bracer is suited for direct assaults and can hold a defensive line under strong kinetic pressure. Guardian Bravo. Height, 236 feet tall. Weight, 1,920 tons. 2-pilot. Its primary weapon is the Arc Whip, an electrified kinetic whip designed to restrain enemy limbs and break their balance. Reinforced arm servos allow high-force grapples. The modified kinematic frame improves lateral movement and stable turning. November Ajax. Height, 246 feet tall. Weight, 1,870 tons. 2-pilot. A patrol-class Jaeger focused on coastal security, equipped with light tactical systems and non-lethal restraint modules. The lightweight frame reduces mass and increases acceleration, allowing fast responses to localized threats and small mobile targets. Obsidian Fury. Height, 255 feet tall. Weight, 1,996 tons. Equipped with dual energy blades capable of cutting heavy composites. Its reactor uses a bioactive component that produces a non-standard power profile. The control system shows motor signal deviations different from Drift 2.0 norms. The frame is designed for high-speed close-quarters combat and reduced optical visibility. Shao Drone Jaeger and hybrid form. Height, 242 feet tall. Weight, 1,740 tons. The autonomous control module replaces human pilots. Drones operate with coordinated combat algorithms and can advance in synchronized groups. When infected by a biological component, the frame structure changes, organic sections appear, strike force increases, and reaction speed rises. The hybrid form becomes unstable but significantly more aggressive. Scrapper. Height, 13 feet tall. Weight, 11 tons. Single pilot operation with no neural link. Fully manual control. Equipped with booster modules for vertical jumps and short-range bursts. Used for reconnaissance, infiltration, and supporting heavy Jaegers. Hey! Subscribe, like, and please leave a comment. It really helps the channel. Even lightweight Jaegers can't jump high. The average vertical limit is 26 to 39 feet tall, roughly the height of a 4-story building. The restriction comes from leg servos that are designed for forward momentum, not vertical thrust. A higher jump would overload the hip actuators and risk structural cracking in the knee joints. Even at this limited height, the landing impact equals the force of dropping a loaded freight locomotive, which requires post-mission inspection. The energy cost of a single maximum jump equals a short-term surge comparable to powering a small industrial facility. Close combat weapons drain power far more aggressively than ranged systems. A full-force strike from a plasma blade or a kinetic mace can demand up to 40 to 60% of the Jaeger's immediate output reserve. This spike is comparable to the short, peak load of a medium-scale power plant switching to emergency output. Because of this, repeated heavy strikes cause coolant consumption to rise sharply, and the reactor enters a high-stress zone where efficiency drops. Maintenance crews treat each full-force melee hit as a high-cost event due to the wear on servos and thermal plates, even though exact financial values are classified. The neck and upper torso sections are the most vulnerable points in a Jaeger's frame. Damage to the cervical actuators disrupts head rotation, narrows the sensor arc, and can blind the Jaeger to targets approaching from above or behind. A direct hit to the upper chest risks power line rupture and partial loss of mobility, similar to losing hydraulics in a heavy industrial crane. Repairing these sections is considered one of the most labor-intensive procedures. It requires detaching the con pod mounts and replacing reinforced plates, making it one of the most expensive repair operations despite the lack of published numbers. Why Jaegers don't use firearms? Traditional firearms are ineffective against kaiju tissue. Standard and even high-caliber rounds fail to penetrate dense outer layers. A Jaeger-scale gun would require extreme barrel reinforcement, generate rapid overheating, and consume cooling resources faster than the reactor can sustain. Urban combat restrictions also prevent using shockwave-producing weapons near civilian infrastructure. At close range, firearms are impractical and risk damaging the Jaeger itself. Maintaining ammunition for weapons of this scale is logistically impossible, while energy-based systems draw directly from the reactor, providing consistent output without physical rounds. Building modern Jaegers requires extensive logistics and rare materials. Each frame uses carbon titanium composites manufactured on specialized assembly lines. A full Jaeger contains hundreds of servos, high-energy reactors, and multi-layer armor panels. Even partial limb damage demands complex disassembly and heavy repair equipment. Drift 2.0 reduces strain but still has limits. During long engagements, neural tension builds up. Poorly synchronized pilots risk short motor signal divergence. Vestibular fatigue can also appear, causing delayed command responses. These issues raise the chance of maneuvering errors. Modern materials remain vulnerable to localized damage. Carbon titanium armor withstands heavy impacts but degrades when exposed to heat-based punctures. Joint hits disrupt kinematic links, requiring servo resets. Mark 6 power systems are sensitive to overheating, which can trigger cooling overloads during intense combat. Hybrids and infected drones pose a unique threat. Biological corrosion weakens armor layers and reduces structural integrity. Organic matter can interfere with sensors and create false orientation signals. Attacks on facilities show that maintenance docks remain vulnerable, as infected units can breach technical sections. Logistics remains a major limitation. Jaegers require specialized transport platforms to move between deployment zones. Movement outside urban areas is limited by terrain, soil stability, and available infrastructure. Long-range transport depends on ships and aerospace carriers, increasing response time. Pilots are a scarce resource. Neural-compatible pairs are uncommon. Many candidates are rejected due to mismatched motor profiles or unstable synchronization. Some pilots are removed from service after experiencing drift trauma, a condition where the nervous system registers phantom pain from Jaeger damage. Being a Jaeger pilot demands physical endurance, cognitive discipline, and constant risk management. But compared to operating a mobile combat unit like a Gundam, the load is still lower. Gundam pilots carry the entire control burden alone, without a partner to split neural strain. Managing a smaller yet more complex machine requires a different level of precision.